Hi, ladies and gentlemen. My name is Ogbonna Chinedu, and this I welcome you to OGM Electrical Academy, where we will be learning introductions to automation 101. OGM Electrical Academy is on a journey to train over 100,000 electrical aspirants or artisans into becoming electrical experts. Here are the high-demand electrical skills we offer: solar installation, CCTV or smart camera installation, electrical building wiring, electric fence installation, automate with OGM, in parentheses, automation, electrical administration, etc. With OGM Electrical Academy, you will learn the theories and practicals of these electrical skills, enjoy 6 months real-time mentorship, job opportunities, certification upon request, and possible licensing with NEMSA. So before we go further, I would love to read out the table of contents that we have here in Introductions to Automation 101, or what we're going to be learning. In as much as today, we're going to be focusing more on the applications of home automation, where the first automation system we're going to be building will be automatic changeover using one contactor. So let's go over to the table of contents. So this is actually a book by Engineer Ogbonna Chinedu on automations. So we're actually trying to start from the basics to learn how automation systems work, or why automation, or even the reason why we are hearing the word automation, or even where automation systems started from. Just like we have it inside this book, automation systems started from the industry, where Ford Motors added them automation processes in their factory to curtail them repetitive tasks in their industry. So from there, we now have more recently more variant types of automation, not only in the industrial area, but it has, graduated and then more recently have gone over to the agricultural sector, hospitality sector, hospitals, homes. Then we have the transportation sectors, and so on and so forth. So where we are going to be looking at as electricians, we're focusing more on applications of home automation. Dicily, I'm going to mention something that will be quite very controversial, just like my own definition of what automation is. I said that automation is the closest that man has gone to become omnipresent. So what am I going to mention that is quite very controversial? So many people kind of misconcept between home automations and smart home automations. When we talk about home automation, it's actually the applications of automation components without the help of internet, like the water level sensor that doesn't use internet, like the automatic changeover that doesn't require internet, and so on and so forth, even burglar alarm systems. But when we now add IoT, which is Internet of Things, to our home automations, we now have smart home automations. So whenever you are hearing smart home automation, we are talking about the advanced variant of home automation, which we are also going to be looking at. But today, on this course, we are only going to be focusing more on home automations, and the applications of home automations. Now, as we have it here on the board, you will notice that we are talking about building an automatic changeover. What is an automatic changeover? Automatic changeover is a device that helps us to change from one source of power to the next source of power without any human intervention. So we can call it ATS, or automatic transfer switch, or and so on and so forth. But they obey the same principles, they do the same thing. So we have several features and the functionalities to several different automation components that we use in building automatic changeovers. So we have automatic changeover that can switch in between 2 sources of power. We have automatic changeover that can switch in between 3 sources of power. We have automatic changeover that can delay before even switching. We have automatic changeover that can turn off generator, turn on generator, or even turn on and turn off generator. We have automatic changeover that can even send you an alarm before making those processes, or taking those actions. We have automatic changeover that we can even pair with IoT to even have the smart variant of those automatic changeovers. So all in this course, we are going to be building 7 kinds of automatic changeover, 7 kinds of automatic changeover. So I'm going to quickly draw the diagram of building an automatic changeover using one contactor, and also explaining the component that is needed to build an automatic changeover using one contactor. Explain the whole component verbatim, how those components work, and what you should expect while trying to play around with those components and then use them and then achieve any automation processes. Welcome back, ladies and gentlemen. Now we want to explain the diagram I have here on my board, explaining it and then as well explaining the components that we can use to achieve this automation system. Just before, let me recap. This is an automatic changeover using one contactor. So what we want to achieve here is to switch in between two sources of power. Probably might be NEPA or generator, as we call it in Nigeria, or it might be your national grid and the generator, or it might be your national grid and as well your solar. It can be any other sources of power, but we just want to what we want to achieve is that the automatic changeover should be able to switch in between two sources of power without any human intervention. So what we have on the board is actually okay. So another thing here is that we have our load, which on the diagram is an alarm, but we're going to be using a pilot lamp. That's what we're going to be using, and then we can as well add breakers, circuit breakers, and voltage monitor. Okay, so these are the components that we're going to use to achieve an automatic changeover using one contactor. Now here are the components. Okay, so this is a voltage monitor. What's the work of a voltage monitor? Voltage monitor allows us to set the minimum voltage that we want and the maximum voltage that we want, which helps us to mitigate any other voltage that is not compatible with any of our system. I'm just trying to break the definition down in a layman's term. So with the voltage monitor, you can set minimum voltage that you can allow to pass, allowable minimum voltage, and allowable maximum voltage to come into the system that you actually applied it on. So with this, you have actually alienated any surges, any power surges that will actually come to surprise any of the components being listed here. The second thing we have here is the timer, the almighty timer. So the timer is also a very wonderful device. The timer, this is an early timer. It works in several ways, but for the purpose of the application we are using it for, we're only going to be using it for one of them, the ways it works for us. This timer can have can open up our circuit and as well close it based on a particular defined duration that we set on the timer. So we can call this is a seconds timer, this is a 30 seconds timer. A 30 seconds timer. So we're going to decipher and also dissect how this timer is being used. We're going to decipher and as well dissect how this timer is being used. So another thing we have here is the almighty contactor. Contactors are actually devices that works with the principle of electromagnetism. So what happens is that when the coil terminal of this contactor is being energized, it pulls the fulcrums and the lever to close a particular contact, thereby making any contact that is normally open to turn to normally close, and any contact that is normally closed to turn to normally open. So this is how a contactor works. So it can be bigger than this. We have more. Okay, we have this contactor here. We have more. So it can be bigger than this. We have multi-terminal contactors and we have our normal contactors. But for the purpose of what we want to achieve in this particular automatic changeover device, we're making use of this normal contactor. So also what we have here is our auxiliary contact. Auxiliary contact doesn't have any coil terminal. It doesn't switch off or switch on based on the power being sent to it, because it doesn't have any coil terminal and doesn't work with the principle of electromagnetism. What actually helps it to actually display its function is actually this guy on top of this contactor. So this is how to place it in. We push this button up and then we connect it this way and it's in. So what happens is that while this contactor is working using the principle of electromagnetism, this guy, which is the auxiliary contact, will as well be working. So lastly, what we have here with us, is the breaker. All of us know what a circuit breaker is, and this is actually a miniature circuit breaker. Circuit breaker helps us to actually open up our circuit when it detects any power anomaly, specifically on the current side. So that's why we call it a current circuit breaker, our miniature circuit breaker. It opens up our circuit whenever it detects any malfunctioning power. It opens up our circuit whenever it detects any malfunctioning power. So these are all the whole components that we're going to be using for this automatic changeover application. Now let's look into these components and what we can obtain from it on the board. Now if we look at this, now one thing that is very very important that you need to know on any of these automatic components or automation components is actually to learn the numbers and the names or the symbols or the representations. Like in contactors, we have the 13 and 14. So whenever you see any number called 13 and 14 on the contactor, we are talking about normally open and normally close. Whenever you see 21 and 22, we are talking about normally close. Whenever you see 31 and 32, we are talking about normally close. Whenever you see 43 and 44, we are talking about normally open. So I think this is actually the aspect where it gets more really professional, technical. You need to understand these numbers. Another way for you to actually know which one is normally open and which one is normally closed, to actually use it in your system, is by making use of your digital multimeter. Okay, so another way to actually know whether your contactor is normally open or normally closed, because it's very very important. Why is it very very important? There are some contactors you get, all the whole contactors, their manufacturers are different. Even so, as their manufacturers are different, so as their representation are as well different. You might see a number that is not probably close to what you know those numbers to be on a contactor. Another way to identify that is to make use of your digital multimeter and then be able to read out the normally opens and the normally close, and as well finding out the coil terminal of the contactor. So set your multimeter. Mine is actually automatic. So for if you have an ordinary digital multimeter, set it at continuity test. Set it at continuity read so that you can be able to know where the contacts are closed and where the contacts are open. Okay. Okay, you can see that this is our normally open. 43 and 44 is normally open, just as we have it on our diagram. So 21 and 22 is normally closed as well, and 13 and 14 is normally open. So press it. With this, we have understood how which remove. With this, we've actually understood what this particular contactor is made up of. So we have two normally closed and two normally open. Then as well, these are contacts. These are contacts as well have normally open and normally closed. Just like the way I show us how to apply it. When we apply it, we can now find out those ones which are normally open and those which are normally closed. So these two at the center is normally closed, while these two here are normally open. So let's test run. Normally closed and normally closed will make a sound. You can see it. Then the other ones are as well will make a sound. Then why this one we need our contactors to be energized before it's normally open, so it's not going to make a sound until it comes on. So we haven't understood that. The same thing we can as well use the same way to understand how even our timer, our relays, and so on and so forth works. So let's go back to explain the diagram on the board. And the components are the contactors, the timers, the pilot lamp, the breakers, and the voltage monitors. Now let's explain the diagram. What happens here is that these are our lines. This our line is the supply, usually utility supply. Utility supply. But when we talk about utility supply, we're talking about the supply that we don't have control over, just like our national grid or our NEPA, just like our national grid or our NEPA. So why this should be our gen supply? So and then what we have down is actually the load that goes to the house. What we have done is actually the load that goes to the house. So when power comes over to this place, you can see what is happening. This is a complete system. Don't look at it as a diagram and then we call it K1. This is our contactor 1. And as much as there is no contactor 2, but we call it contactor 1. So this is a complete system. So when power comes over to this guy, it goes over to this side. When it comes over to this place, it goes over to this place. When we start making the connections, we're going to understand it better. So what else happened is that we use this guy to energize the coil terminal of our contactor. Power comes over to this place and energize the coil terminal of this contactor. So when the coil terminal of this contactor comes on, power goes to our load and as well energize this guy to shout. What we want to achieve with this particular diagram is that I know that in Nigeria, there's what we call NEPA alarm. We always want to know when our light comes on or when NEPA brings their power. So what happens is that whenever light comes, the alarm starts sounding, telling us that the national grid have actually resumed their power. While this is on, we can as well use this timer to delay the NEPA from coming to our contactor before it comes into it. But for the purpose of what we are doing now, we want the timer to actually carry out the function of alerting us that NEPA power is in our building. So we will now go over to trying to install this, test running it and see how it works.